Okay, so let's go ahead and get started. Determine the percent yield for a reaction between 98.7 grams of Sb2S3 and excess oxygen if 72.4 grams of Sb4O6 is recovered along with unknown amounts of sulfur dioxide gas. So step one is you want to write out your equation. So, well, a lot of writing on here, but don't be confused. Sb2S3 and oxygen, O2, is recovered along with amounts of sulfur dioxide gas. So sulfur dioxide gas and this right here, Sb4O6. Okay, and we're also given these amounts here, 98.7, 72.4. And it also tells us that this is the excess, so Sb2S3 must be the limiting reactant, which makes us really happy because we don't have to do the math on this one, so yay, we're happy now. Okay. Because eventually our goal is this. Our product divided by our limiting reactant equals our percent yield. So we know our product, we already know our product is 72.4 right off the bat. So we're solving for the theoretical yield, or the LR, the limiting reactant, basically. So if we start our math here, we can go ahead and start our math. We just need to solve for this one only. We don't need to solve for oxygen because we already know it's our excess. And we don't care about the excess here because we're only trying to fulfill this equation right here. We're only trying to find the limiting reactant so we can divide it. Okay, so let's go ahead and do this. So I have this chart here. Where is my math? Oh, here is my math. Okay, let's take this one step at a time. I have a blank piece of paper. Okay, that's better. So this is our original equation here, and we're given 98.7 grams of Sb2S3. So we're in grams and we want to go to moles. Okay, so we're going to divide by the molar mass of Sb2S3. So using a periodic table, you do Sb, which is 121.8 times 2. That should be 243.6. And then you want to add it to sulfur times 3. So you take sulfur 32 times 3 is 96. You add them both together, and you should get 339.6, and that goes on the bottom because you're dividing it because you're going up. So now you successfully went from here to here on your given side. Now you want to go from mole to mole. Okay, so we're given always goes on the bottom when you're doing mole ratios. So your mole ratio here is 2. Oh, where am I? 2 here in your balanced equation. And then you're going over here to Sb4O6 because this is what you have a digit under. We don't care about this because we don't have any numbers. It's unknown. Well, this is unknown also, but we have some numbers here. So we're going to go ahead and use this. So 2 here, 1 here. Given always goes on the bottom. So this is our given here, and then our unknown is this. And that's your mole to mole ratio. Now you're successfully over here on the unknown side. Now you want to go from mole to mass, because that's where you started from, mass over here. So we're going back to mass. So we have to multiply Sb4O6, or multiply this number by this molar mass. So what is the what is the molar mass of Sb4O6? The answer is 583.04. Now all you have to do is take this, plug it into your calculator, and you should come out to get 84.7. Now based on your chart, based on this chart, percent yield equals actual yield. The product divided by theoretical yield, the limiting reactant. So now we know the limiting reactant. This is the limiting reactant, 84.7. So this is the number that's going to go on the bottom. So let's get a marker here. Get some free space. Here, this is some space here. So 84.7 goes on the bottom. 84.7. And on the top, the actual yield the actual yield, or the product, and the product is given to us at 72.4. So we can go ahead and use 72.4, and if we divide this, it should give us the answer. And then multiply it by 100, or move the decimal over twice. It's the same thing. It should be 85.47 I have on my calculator here, which rounds to about 85.5%. And that is your final answer.